All right, I'll talk a little bit about the National Ecological Observatory Network and our attempts to make our data as fair as possible. A little bit about NEON. We are funded by the National Science Foundation and operated by Battelle. We monitor 81 freshwater and terrestrial sites across the United States. And we are processing over 4 billion data points per day. These are currently transformed into 165 data products that are freely available to the public, with 17 more that are being developed right now. So we have 182 data products in our catalog. These are ranging from genomics, both organismal and environmental, population dynamics, from small mammals, fish, birds, and mosquitoes, beetles, ticks, etc. Surface atmospheric fluxes, other atmospheric parameters, remote sensing, and more. In addition, we also are collecting over 100,000 samples per year, and these are sent to our biorepository at Arizona State University. And currently we have over 260,000 samples in accession. All in all, the data that we have is about 1.5 petabytes of data in storage, and we are adding about 400 terabytes per year. So it's a really huge project. It's the biggest ecological data project that has been in existence, I believe. So, and let's see if we can get the slides going here. So those data types, we divide them into 3 major divisions as viewed by our processing pipelines. First, we have our sensor data that we are streaming into headquarters every day. The raw data is coming in as frequently as 40 hertz data, and we're publishing those as frequently as 1 minute data. We have our observational data where we have people on the ground. They're collecting data manually, or they're collecting samples. They're collecting multiple times per year, or even multiple times per week, or rarely once per every few years. Our remote sensing, which is done on the airborne platform, this small plane, as you might see above. The flight season runs March through October. Our hard drives are shipped back to our headquarters for processing. There's a lag time in publication, and this can run from several days to several years, depending on the type of data. So for example, sensors can be really quick because those data can be processed automatically and published. But with some of our observational data where we're sending samples to external labs and we have to wait for those labs to process the samples and get data back to us, it can take quite a while. So in terms of FAIR, the data, we're actually doing quite well on findable and accessible. All of our data are freely accessible through our data portal GUI, and also we have multiple endpoints through our API. We also share our data through other aggregators, such as the Global Biodiversity Information Facilities, Barcode of Life, Ameriflex, Data One, and others. So we have a lot of machine readable metadata that makes this possible, and other aggregators can pull our data through various means. The success of that is shown through this graph on the right, which from right to left, or dark blue to light blue, we're showing data requests, data download or download volumes, and then the number of API users, or which we get from unique IP addresses over the last 4 award years. And those numbers are increasing at a fairly good rate. So what we're going to do here is actually skip over the I, because the I is very difficult, and we don't really have time to talk about that. But I do want to touch on our releases, and we're really going to talk about reusable here, and intertwined with that is reproducible and citable. For NEON, since we're this huge observatory and we have so many thousands of people dependent on our data, getting data out quickly is important, as is our data quality. So we need both. So what we've been doing is providing provisional data, both during the construction of NEON, which started in 2012, and initial operations, which started in 2019. And then rolling out provisional data as soon as we get it. We put out our first data release, a static snapshot of our data in 2021. And so this was our first reusable, reproducible set of data products available to the public. And what that represented was this minimum of 1 year of our data products at almost all of our sites, starting with initial operations. All of those data product releases have a DOI that was minted by DataSite with all of the appropriate metadata, and they're fully citable. So creating that release, what we found was it takes months of cross-team coordination, and that's both within all of our pipeline science teams to make sure that the data are quality checked and republished if needed. And then also between our science and our cyber infrastructure teams to go through all of the checking and the testing, making sure that that release is really perfect and ready to go, and then finally published for public consumption. I'm going to take a step back a little bit just to explain a little bit more about that release and how it's constructed. One thing I wanted to note at the beginning, and I failed to do so, was that two of my co-authors here are here at the meeting, also participating remotely. Steve Jacobs and also Dawn Lentz. Dawn Lentz has also been heavily involved with the technical design of our releases. So I wanted to let you know that she is also participating. In terms of our data granularity, our stored files are indexed. We have many thousands, of course, of files, and our database stores metadata about each of our files. Our users and ourselves, we cluster our files by data product, by field site, and year, month, and then we have each data product by site, by month, documented with human readable and machine readable files. Those XML files are using the ecological metadata language schema. So on the right, this is our data availability chart, and each row is a site, one of our sites. So this is 2D wind speed and direction, and then each column is a month of data. And so the blue rectangles are showing availability of that data for the end user. So this is just an example of a downloaded data package where I downloaded a very small example of 2D wind speed and direction, basically just 2 months, June through July 2021, at our Central Plains Experimental Research Site in Colorado. And what you see here is the first month, June, here is several months of data files, and then some metadata about that specific month, the sensor position files, the variables, the README and the XML, and that it's tagged with our release 2022. So it fit within our release, and it's in there. The second month was in July, and it was still provisional. So it's tagged with our provisional tag, and it also has data and metadata within it. And then the whole package has some more metadata associated with it, some documents. And then it all has a manifest, and that manifest tells the user, here are all the files that you've downloaded, and here are the release or the provisional status that those files are tagged with. So basically all those files have those tags of what releases that they belong to. So again, just to reiterate a little bit, as you look at this diagram on the left is just a time diagram. As time marches along horizontally down, we have provisional data until we hit this 2021 release. We take a snapshot of data up until a certain point of time where we say, yes, the data is ready. 2022 comes along, we take another snapshot, and then we'll do so again in 2023 and 24. So we have these annual releases. And on the right, what we do for discovery, I'm sorry about that, is we provide the users with the option, do they want the latest in provisional, the latest release in provisional, or do they want to go back and just get the most recent release without the provisional data, or do they want to get older releases? And so over time, we'll be providing them with these options, and so they can compare across the different releases. And of course, what we hope is that every single release will have better and better data if we do have to do any corrections there. And we hope that they will always be able to use the best data possible. But if users ever want to go back and compare data or go back and do a reproducible analysis, that will always be available. And so the same thing with our time series viewer that is available for some of our data sets. They'll be able to choose which release they can view and take a look at that. So we do have some exceptional cases, of course. Nothing is perfect. Our remote sensing data products, a lot of the data are really huge. The remote sensing data actually takes up the bulk of our volume. If not even though it's only 29 of our 182 data products, the volume is huge. So we only can provide the most recent release available. So it's only available for the year, and then it actually gets replaced by the next release, unfortunately. So that is a challenge for us. For samples, we do provide international geosample numbers. These are persistent, globally unique identifiers. And we do have Darwin Core records for these, and we do update them as the samples are used, processed. Otherwise, where the records are altered, we do keep up-to-date records, and they're managed by the biorepository. For provisional data, which we provide over time, we have partnered with the Environmental Data Initiative. And what we provided guidance for users to do is that when they submit a workflow to EDI for publication, they can also provide our provisional data, including their outputs and their code, and get a DOI on that. So there is some reuse possibilities there, including some reproducibility. The last little bit here is documentation for those releases. We do provide documentation on changes between the different releases. So for example, here's a table that shows that for 2D wind speed, for example, we say for between release 2022 and 21, we tell users that the data reprocessed with an updated algorithm to resolve some errors, and that we corrected some sensor orientations and their resultant wind directions, and where to go to get some more information on that. So in conclusion, we've found some really major successes in achieving R for reuse, also some reproducibility, which is intertwined with that for the bulk of NEON's data products. And we hope to achieve some bigger successes in the future. Some challenges, as many have noted before, the R affair is difficult to achieve, as is so much else of FAIR. Provisional data still needs to be preserved by the users, and because we want to be able to update and improve the quality of the data over time. Large data sets are very expensive to make reusable, so that's always a challenge. And then something I didn't really touch upon in this talk, but something to think about, is providing users with data and metadata in the desired granularity is also a challenge. We always end up providing users with more data than they actually use. And so they are, when they are reusing our data, they are essentially subsetting data from what we provide them with. And it's always a topic of discussion. So that's all I have, and thank you very much.